Have you ever made a mistake with a pencil and watched, almost like magic, as a simple eraser wipes it away? It feels like you are turning back time, making the error vanish completely. Think about the last time you were writing or drawing. You are focused, your hand is moving, and then it happens. A wrong letter, a crooked line, a number that just does not belong. Your first instinct is to reach for the eraser. You trust it completely. You press it to the paper and begin to rub, fully expecting the mistake to disappear. We perform this action thousands of times without a second thought. We accept that erasers erase, but this simple act hides an invisible battle taking place on the surface of your paper. Understanding this battle means we have to look deeper, not just at the eraser, but at the pencil mark itself and the very paper it sits on. This is where the real story begins. First, let's talk about the pencil. A pencil does not use ink. The part you call pencil lead is actually a mixture of two materials, graphite and clay. Graphite is a form of carbon, the same element that makes up diamonds. But unlike diamond, graphite is made of flat sheets of atoms that slide off each other very easily. When you write, you are not staining the paper. You are actually scraping off tiny flakes of graphite that get left behind on the page. So a pencil mark is not a liquid that soaks in. It is a physical layer of solid particles sitting on top of the paper. This is a crucial first clue. Now let's zoom in on the paper. To our eyes, a sheet of paper looks perfectly smooth and flat, but under a microscope it tells a very different story. Paper is made from wood pulp, which consists of countless tiny strands called cellulose fibers. Up close, the surface of paper is not a flat plane. It is a dense, tangled forest of these fibers. It is rough, uneven, and full of microscopic peaks and valleys. This texture is what makes writing with a pencil possible in the first place. As your pencil moves across the page, the abrasive, fibrous surface of the paper grinds against the pencil tip, shearing off those little graphite flakes. These graphite particles become physically lodged and trapped among the web of paper fibers. They are stuck, held in place by a force we all know, friction. So, to erase the mark, you have to find a way to pull those tiny graphite flakes out from the tangled maze of paper fibers. Just rubbing it with your finger will only smudge it. This is where the eraser enters the scene, and it is not just a simple piece of rubber. Modern erasers are marvels of materials science. They are typically made from a synthetic rubber or a vinyl polymer, but the material alone is not enough. They have special ingredients. Eraser manufacturers add in softeners, which make the eraser flexible. They also add fine, gritty fillers, like pumice. This grit is the eraser's secret weapon. The graphite particles stuck in the paper fibers, and the specially designed eraser ready to take action. When you start rubbing the eraser on the paper, the first thing that happens is friction. The friction between the eraser and the paper generates a small amount of heat. This heat is very important. It slightly warms up the polymer material of the eraser, making it softer and a little bit sticky. This slight stickiness is the key to the whole process. The eraser is becoming prepared to grab onto something. But it is not just getting sticky. The friction is also causing the eraser itself to crumble away into those familiar little color dustings. This crumbling is intentional. It ensures that a fresh, sticky surface of the eraser is always being exposed to the paper and the pencil mark. Now we come to the most important force in this entire story. It is a force stronger than the friction holding the graphite to the paper. That force is called adhesion. Adhesion is the tendency of different particles or surfaces to cling to one another. It is like a molecular level stickiness between two different things. The polymers in the eraser are specifically engineered to have a very high level of adhesion to graphite. In simple terms, the eraser is much stickier to graphite than the paper is. As you rub the heated, softened eraser over the pencil mark, its sticky molecules come into contact with the graphite particles. The adhesive force between the eraser and the graphite is now in a tug-of-war, with the frictional force holding the graphite to the paper fibers. And it is a battle the eraser is designed to win every single time. The eraser's molecules lock onto the graphite flakes with a powerful grip. This grip is so strong that as you continue to move the eraser, it literally plucks the graphite particles up and out from between the paper fibers. The eraser is not dissolving the mark or bleaching it. It is physically stealing the graphite away from the paper. So what about those little crumbles and shavings that the eraser leaves behind? They are not just bits of used up rubber. If you look closely at eraser shavings, you will notice they are darker than the eraser itself. That is because they are a combination of the eraser's polymer material and all the graphite it just stole. The eraser sacrifices tiny bits of itself, which trap the graphite inside them and roll away, leaving a clean surface behind. Every time you erase, you are leaving behind little clumps of rubber filled with the very mistake you wanted to remove. This is also why cheap, old, or hardened erasers do not work well. If an eraser is too hard, it cannot generate enough heat and stickiness. A hard eraser does not have the adhesive power to grab the graphite. Instead, its abrasive material just scratches and tears the paper fibers, making a mess. Some erasers, like the pink ones on the ends of pencils, contain a fine abrasive powder that helps scrub the graphite away, but the principle is the same. They rely on the eraser's material being stickier to the graphite than the paper is. It is a calculated victory of adhesion over friction. The entire process is a carefully engineered sequence. Friction creates heat, heat creates stickiness, and stickiness gives the eraser the power to pull the mark away. It is a beautiful example of physics and chemistry working together to solve a very common problem. So the big insight is this. An eraser works because it is designed to be more attractive to graphite than paper is. Think of it like a magnet for carbon. While paper fibers can trap graphite particles loosely, the eraser's polymers form a much stronger bond. This principle of selective adhesion is a cornerstone of materials science. It is about creating materials that stick to one thing but not another. The genius of the eraser is not in its ability to rub, but in its ability to grab. It is a tool of adhesion, not abrasion. It wins the invisible war on your page by being the stickier opponent, cleanly lifting the mistake and trapping it. The next time you erase a mistake, take a moment to appreciate the science in your hand. You are not just removing a mark. You are commanding a tiny, powerful force of physics. This simple object is a reminder that even the most ordinary things in our world are governed by extraordinary principles. From a pencil mark to a skyscraper, everything has a hidden story of science. The world is full of these secrets, waiting for us to ask, how does that really work?